Here we need to find the 5 remaining trigonometric functions for an angle theta. We're given that cosine of theta is equal to 2/3, and we have that theta is between 3 pi over 2 and 2 pi. That puts theta in quadrant 4. I'm going to draw a little diagram. Since theta is in quadrant 4, we're going to draw an angle that terminates in quadrant 4, draw a terminal side. We're going to actually make a right triangle here. Cosine of theta is equal to the adjacent side over the hypotenuse. So we're going to write that the length of this side is 2, that's the adjacent side, and the length of the hypotenuse will be 3. From the Pythagorean theorem, we know that the remaining side should have a length that's the square root of 5. When we find our trigonometric function values, we need to remember that theta is in quadrant 4, because that's going to affect whether the result is positive or negative. We're going to use this as our reference triangle. So we want to find the sine of theta. Sine is the opposite over hypotenuse. So we'll have the square root of 5 over 3. But in quadrant 4, sine is negative. So sine of theta must be negative square root of 5 over 3. Tangent of theta is equal to the sine over the cosine. So we'll have negative square root of 5 divided by 3 over 2 divided by 3, which is the negative square root of 5 over 2. Secant theta is 1 over cosine theta, so we'll have 1 over 2 divided by 3, which is equal to 3/2. Cosecant theta is 1 over sine theta. So we get 1 over negative root 5 over 3. So it's negative 3 over root 5, which is negative 3 root 5 over 5. And then lastly, cotangent of theta. Cotangent of theta will be the cosine over the sine. And if we put in those values, we'll get that cotangent of theta is negative 2 root 5 over 5.